Good morning, dear students. My name is Ansar Pasha. Today we will learn about a very interesting topic which is very important in your CBSE grade 10th and as well as in your plus 1 and plus 2 when you write any competitive exams like JEE or NEET. So let's understand a very interesting topic. What is that topic? Actually, without that energy, we can't able to see even this video, and I can't able to make this video. What is that? I think you people getting that. It's about light reflection and refraction. So let's explore a light chapter, light reflection and refraction. About light, you know that light is a form of energy. Light is a type of energy and it's an electromagnetic wave. It's a electromagnetic wave and which is having a speed nearly equals to 3 into 10 raised power 8 meter per second in vacuum. In air it varies like 2.9 and in different mediums it is having different speed. Like a light speed in different mediums differ. Like in water or in glass, if you take light speed in glass, it's a 2 into 10 raised to power 8 meter per second. So there is a slight changes because of the denser density of the glass. Its speed decreases. Now, so we'll do quick recap of the reflection and refraction. What do you mean by reflection? It's just a bouncing back of light, bouncing back of light to the same medium. And a refraction is a bending of light when it passes from one medium to another medium. When it passes from one medium to another, one medium to another. You already studied in your grade 6, 7 and 8 about reflection and refraction, and you can see the fully polished surfaces are reflecting the light and the rough surfaces they will not reflect the as compared to the fully polished surfaces. Fully polished surfaces will produces the images, rough surfaces cannot. And the bending of light, you have seen that if you immerse a pencil inside the transparent glass which is filled with water, you can see the pencil looks like it was bent, and the coin which is immersed, which is dipped inside the glass of full of water, it looks like it is little bit, it looks like it is appearing little bit up. That is all due to what? Reflection and refractions. Now next, we in this chapter we need to study about the, and in grade 7 and grade 8 you studied about the image formation by the plane mirror and image formation by the spherical mirrors. In spherical mirrors we have, in plane mirrors, and about plane mirror you know already. In spherical mirrors we have two types. Which are those? Yes, first one is a concave mirror, concave mirror, and another is convex mirror, convex mirror. So concave mirror shape is, it is curved inward and it is having a reflecting surface which is curved inward, and convex mirror which is bulged out and it is having a reflecting surfaces which is bulged out. So light should fall here to reflect, light should fall here to reflect. If the light is falling here, it will not shows reflection. So this is the this this is the reflecting surface, this surface, and here light should fall on this surface to show a reflection. From this side we can't see any reflection because it's a coating, it's a done, okay. So from this side it is a coat, okay na, it's a opaque. From this side it is a reflecting surface. Now, we studied that in your grade 7 and grade 8, that concave image forms virtual concave mirror, sorry. Concave mirror forms real and inverted images with magnified and diminished images. A concave mirror forms, it forms real and virtual. Real means which forms on the screen, which forms on the screen. A virtual means behind the mirror, behind the mirror. Okay, the real and virtual image. Next, if and also it forms inverted image, inverted image, inverted image, which is upside down, upside down. What do you mean by upside down? For example, if you place a candle like this in front of this concave mirror, the image you will see in the mirror or on the screen, it may be looks upside down, like flame look appears down and the candle bottom will be appears up. If this is A and this is B, B appears down and A appears upside down. This is the inverted image. Okay, and like screen, like projects, projectors and the film on film theaters, what you'll see the cinema, those are what example of real images. And erect images, it forms also erect images as it is, like plane mirrors. Okay, upright images, upright images. Okay, so usually we'll use the plane mirrors which shows us upright images as it is. If your head is up, it shows your head upside only, so upright images. And as well as it shows that magnified and diminished images, it shows magnified and diminished images. So here I will write for the concave, this is all about what, concave forms. Okay na? Concave forms all these type of images. It forms diminished. Diminished means a small or very small, and also it forms, magnified images, magnified images, magnified, diminished and magnified images, which means enlarged images, enlarged bigger images. So you know about a magnifying lens. That magnifying lens will give you the, if you want to read in small letters, it will magnifies the images, means it zooms the images, it gives the big images, which from that we can easily able to read. So this a concave mirror forms diminished, small and the bigger images on the screen and inside the in one condition it forms the virtual and erect, that is what, when you bring near to the mirror. So we learn in this chapter that how it forms this all kinds of images. We will understand the ray diagrams and the image formation, image diagrams by the concave mirror as well as the convex. And convex forms, it forms only virtual and erect images, virtual and erect images, and it forms diminished and highly diminished images, diminished, sorry, diminished and highly diminished, diminished and highly diminished images, highly diminished images. It means it forms virtual and direct images, upright images, which forms inside the mirror and nothing but behind the mirror, and it forms smaller and two smaller images. In this chapter, we'll learn about their how they forms these kind of images. Okay, so start. We'll start in this chapter. Mainly, there are numericals based on the image formations, and we have spherical lenses also. You know that concave and convex. You aware of concave and convex lenses, and those lenses also forms images. We'll study their image formation diagrams as well as the numericals based on the image formation diagrams. Then power we have all this we'll study okay one after one. Now we'll study about the ray diagrams first. The ray diagrams are very important. Ray diagrams. Ray diagrams. A single line which is having direction is called as a ray, and the group of rays are called as beam. Like a pillar which contains the number of rods is called as a beam. Here also, if you take more than one or two or three, those are called as beam of light, ray of light. Okay, in mathematics, we have seen that line which is with the line with the direction is called as ray. If group of rays are called as beams, and the light rays, if they are converging at one point from the different point, like this. So these are called as convergent rays. Convergent rays. If from one point, if they are diversing, if they are diversing, means they are changing their path. It means they are divergent rays. Divergent rays. Okay. Now we have to study about the how concave reflect the rays. So this concave is having a center reflecting, okay, na? In this reflecting surface, it is having a center point which is called as a pole, and the length of the concave mirror or convex mirror is called as aperture. Is called as aperture. This is the line which is passing from the center of the curvature, and the principal focus is called as principal axis. Principal axis, which is straight, which never bends, whether it is in a convex, concave, or either maybe it in a mirrors or in lens, it will never bends. It goes straight. And if you take a parallel ray which falls on a mirror from the infinity or somewhere, it reflects and it passes from the principal focus. I don't have scale here, sorry, but you should use scale to draw this. And you know that in between incident ray and the reflected ray, we have a normal line. That normal line from this point, from the incident point, we have to take a normal which is passing from the center of curvature. Center of curvature. This is our incident ray and this is our reflected ray. Here we have angle of incidence and here we have angle of reflection, okay, for this ray. And if you take for the convex, or yes, for the convex mirror, same, a pole, but the difference is what? Here in convex mirror we have focus this side, the right side, and the center of curvature is this side, because its circle, imagine a circle will complete the left side, that's why it is having its imaginary center this side. And here it is the part of a sphere, this sphere is this side, that's why it is having center this side. Okay, na? The principal focus is the principal focus divides the distance from pole to center of curvature equally in a two parts. The distance between center of curvature to pole is called as radius of curvature. And if the parallel ray falls on convex mirror, it reflects it reflects, and it looks like, it appears like it is reflecting from the point of f, point of f. And here also the normal ray from point of incidence, it will the passes from the center of curvature, center of curvature, sorry. So this is our normal, the dotted line is a normal. Similarly, if we take another ray of light, same diagram we will take P, F, C. If light ray passes from focus, then what happens? Just it behaves vice versa. What? If light ray passes from the parallel to the reflecting surface, it bounces back from the point F. Similarly, if light ray falls or incident from the point F on the reflecting surface, sorry, here I have taken the concave mirror. So then the light ray reflect and it becomes parallel to the principal axis, parallel to the principal axis. Here also the normal line which passes from the point of C, nothing but a point of curvature. If we take a point of a convex mirror, here P, F, C, and if it appears like if it incident at point F, if it appears like it incident at point F, here also it behaves vice versa, it reflects and becomes parallel to the principal axis, parallel to the principal axis. So here also our normal line will passes from the point of curvature. Next, if you take a light ray which passes, which incident from the point of C, then this is the point of incident. Okay, from here it is incident at this point. What happens in this case? Only in this case, the reflected ray will be retrace its path and it will goes on straight, and the normal line is also lies on the same plane. Here the angle of incidence is equal to 0. Because of this reason, angle of reflection also 0. Theta I, okay, we can mention with the theta I is equal to theta R. According to the laws of reflections, theta I is equal to theta, that's why it is 0. And here in convex mirror, this is point of P and F and C. If it appears like the point of incident is point of incident at C, means the reflected rays also retrace its path in this case similarly. In both cases it behaves similarly, the ray of light behaves similarly. If we take a last ray, if it incident exactly inclined to the point P, in this case the normal line will be passes through the principal axis, and it reflects. What is the angle? With the same angle it reflects, it goes like this. Okay. Similarly, if you take in convex mirror also, the light which falls at the inclined to the point P, inclined to the point P, it bounces back from the point P, inclined. So these are the ray diagrams. These are very important to understand the image formation by the concave or convex mirror, or for the convex lens and concave lens. What? it's a ray, it's a single line is a ray, group of rays are beam. Okay, if the rays are coming from the different point and they are merging at one point, those are called as convergent rays. If they are diverging from the point one, from one point to the different points, those are called as divergent rays. Here incident rays parallel to the principal axis on concave, it bounces from bounce back and passes through the point F, and similarly it happens here, but little bit there is a change. It will never passes through exactly from point F, but it appears like it is passing from point F. So these are the difference. Okay, you can see here the all diagrams you can compare like that. Okay, they are little bit same, but just here exactly light passes from this, these are the from that point, but here it appears like it is passing from those points. In these cases the both are same, and here in this case also they both are same. Next we have to study about the image formation by the concave mirror. Image formed by the concave mirror. Image formation by concave mirror. What? So if you take a concave mirror and the principal axis is very important. It is for our reference. And there is a center of the reflecting surface is called as P, and we have, just imagine we have a center here, and so exactly between of C and P we have F. If we are taking parallel rays which are coming from the infinite distance, which are coming from the infinite distance, and they are incident at the reflecting surface of a concave mirror, then the reflected rays will passes through the point F, like how I shown, whether it is up or below the principal axis, both will be same. And okay, here I am taking two rays because to get any image we need at least two reflected rays. Where the reflected rays are meeting, there we will get the image. Here the reflected rays are meeting at point F, that's why we will get an image at this point. For example, if object is at the infinity, this is the infinity, just imagine A, B, here we will get a image which is outside the mirror, means here we need to place a screen, without screen we can't get the image. Here we need to place the screen, then we will get the image of this object at the point F. If the image is forming on the screen, it means it's a real image. And